In the previous video, several of you asked how I was able to keep my composure while working on some of this equipment. And I'll answer somewhat rhetorically. You can tell a good bit about how long somebody has been doing service on equipment by the reaction that they have when adverse things happen.
Go ahead.
Go ahead.
Holy shit!
That was a really nice one. Okay, getting on with our little project. I removed the pinch rollers and sent them out to be rebuilt. And again, we're going to be using Terry's rubber rollers. And I'll put the web address back up on the screen. I put it on the last video. I've heard nothing but good things about him. I've had some interaction with him through email. He seems like an awesome person. He gets back to you really quickly. He really seems to know what he's doing. So I'm pretty excited to see how these turn out. After the fact, I think I found out that he also does idler tires, and I could have sent my idler tire out to be rebuilt by him as well. But I had already ordered those replacement ones from fixyouraudio.com, so I'm just going to go with those this time around. But it's good to know we have these couple of resources out there still, because this stuff's starting to get old. All right, let's look at this. So here's the pinch roller holder, and you can see this pin I have just partially out, and there's these two little spacers, and one goes on either side, and the roller goes in the middle, and you can see how cruddy that is, the dried up grease. We'll need to clean all that before we replace the roller. But something that's of note, and this is why I want to show you this, when you go to take these apart, you'll want to know that this pin is not totally straight. If I measure the one end of the pin right here, we'll see that it's almost 2 millimeters. You see that? Just about 2 millimeters. And if I measure the other end of the pin, to get it clear, I have to get it all the way down at the bottom here. I don't want it to fall out on the floor. We get right on the bottom. You could see it's 1.94, 1.95. It's just ever so slightly smaller. That's very important because these holes are drilled the same way. So when you remove this pin, there is a specific direction you have to pop it out. Now you're not going to know which way it is until you start popping the thing out. But what I suggest is make yourself a little anvil. So I have this block of wood I use to pound on, and I put this little piece of angle iron in there, and I drilled a little hole so that the pin can go into there. I then took a punch, and this one was a straight punch, and I tapered it on the grinder, and then I put it in my drill press and sanded it smooth. And then that kind of course, when you grind things like that, it softens the metal. So I re-tempered it by heating it up with my torch and then dipping it in oil when the color just got right. And you can see how there's a little coloring here. And then you can check it with a file to make sure it skates off of it, that it's hard. So it hardens this so it doesn't mushroom over when you pound with it. Or you can just find a drift punch of this diameter. It has to be pretty small, though. It has to be like a 2 millimeter punch. Those are hard to find, although they're out there. And what you're going to do is you're going to take this and line it up and then tap it ever so slightly. Once this pushes through, if it's still tight, then you're pounding it the wrong way. Turn it around and pop it through the other direction. The idea is, if you're on the skinny side of the pin, once it pops through this first plate right here, it'll just fall out the other side. It'll be loose. So you could see this pin is loose on this side, but it's tight on this side. So you want to drive it out this direction. If I drive it through this direction, it's just going to elongate or open these holes up, and then this will be loose and you'll ruin it. So be very careful when you're removing this pin. It should pop right out. If not, try the other side. Once you're done, put it back together like I did here. Take a little piece of tape, wrap it around like that, and then place it in a little poly bag so nothing gets lost. These are your friends. Anytime you get these bags when you order parts like from Mauser or DigiKey or something, keep them, because they're very good for this sort of thing. It's good for protecting little parts and keeping them together. Because this is going to be several weeks before I get these rollers back. So I don't want these to get lost moving them around. Another suggestion that some of you made, which was an excellent suggestion, was to remove, if you remember on the last video, this outer ring here, this grip ring on this reel is a little bit warped. So it kind of has a little bit of a wobble to it. This one is perfectly smooth and perfectly round. So we could, you can disassemble these. You pop this little hubcap off, you take the little clip off the top, this whole thing slides off. Then this is press fit. So by pulling this outer white ring off and this black ring right here off, they're just press fit onto the plastic. This comes off, then this spring, this pulls off, then the spring under it, and then this just pulls right off. And you can swap them back and forth, because this is the take-up reel when you're doing play mode, when it's playing. So this is the one that needs to be the smoothest. If I didn't have another one of these coming in, I would probably do that. But if I can make them both be good, I would rather do that. Make this as perfect as possible. Now, somebody was saying that this really doesn't make much of a difference because the pinch roller and the capstan hold the tape tight on the head, especially since this is a dual capstan system. In other words, these two capstans right here drive against the two pinch rollers, and it holds a specific tension across the tape as it drags across the head. And therefore, this isn't going to have a whole lot of influence, but it will in ever so slightly, because if this is wobbling a little bit and it's varying the speed of the take-up, it's going to vary, it's going to put a little tug. It's going to be like taking the tape and going tug, 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 tug like that. And even though the capstan and the pinch roller are holding it tightly against this one, that tiny little bit of tugging will slip through there ever so slightly. Remember, it's just friction fit between these and the tape. So, and yes, this is splitting hairs, but what you have to understand is on the higher end tape decks, when you start getting into the higher frequencies and the really low frequencies, tiny little variances like that will affect the ability to reproduce those frequencies. In the mid-range, it's not noticeable as much. So you don't really hear it when you're listening to actual music, but if you're listening to something that has a lot of cymbals or a lot of really high frequencies, or something that has very low frequencies that are very distinct, it will distort the sound if you have any kind of variance of the movement of the tape. The idea is that tape has to drag across that head at a very smooth and consistent rate. It can't change in any way, or you get wow and flutter. That's what it is. So, being that this reel is small and it runs fast, it'll tug at a rapid rate, so that'll give you what we call flutter. All right? If the capstan drive itself, it spins slower, more slowly. If it varies in speed, then it'll kind of pulsate up and down. That's called wow. So really, wow and flutter are the same problem, only at different rates, if that makes sense. So that's what we're trying to eliminate here. And yeah, it sounds crazy that you scrutinize all these things, but as I said before with other things, it's death by 1,000 cuts. When you have multiple little mechanical problems, each one adds to it. Each one individually is not going to make enough difference that you're going to hear it or notice it, or the average person at least won't. But when you start getting into multiple ones adding on top of one another, all of a sudden it becomes very noticeable. And the more complex the tape transport system is, the more probability that that's going to happen. Some of these really cheap, inexpensive, simple built transports sometimes have an advantage because there's less things to go wrong. So even though they may not regulate as well or reproduce high frequencies or low frequencies as well, you can fix the problems. You know, simple designs have simple problems. Complex designs can have complex problems. At least that's kind of what I've found out with these. Again, I'm not an expert on tape decks, and I haven't worked on a whole lot of them other than what I had to work on. And I've never worked on a DAT, a DAT, digital audio tape. I can imagine those would be 10 times worse. I did a lot of work on video decks back in the 80s and early 90s. I even worked on a lot of those great big Grundig reel-to-reel video tape decks. We used them in the cardiac cath labs. The head on those things was that big around. It was huge, and it used 1-inch wide tape. Really crazy. It was a very expensive thing. They weighed about 80 or 90 pounds, and we used them to record heart studies in cardiac cath labs. It was the first video cardiology of its time. Prior to that, we used an Arri Techno 35 millimeter black and white film camera, and we looked at individual frames of a film at 30 frames per second. Anyhow, I'm getting kind of off topic, but long story short, we want these things to be right, so that's what we're going to do. All right, let's get to work on this power supply and see if we can't get it cleaned up, and along with this chassis. This is such a mess. And no, I'm not going to recap this whole thing. I think that would be a fool's errand in this instance, because these Nippon Chemicons are usually pretty good. I will replace the orange leaky low leakage capacitors, as I call them, because so many of them so often go bad. But luckily there aren't very many of those on here. There's very few, but there are a few of them in critical areas, and we will replace those. And the power supply capacitors are going to get replaced as well. So let me get some of these wires freed up, and I'm going to redo these wire bundles. They're kind of a big rat's nest right now, and I don't know that anybody has worked on this. I don't think, but I don't know. But nevertheless, the wires are kind of messy, so they need cleaned up. So let me get these out, and we'll start to work on the board. All right, time to do some solder and chat. And I'm probably going to block the camera half the time on this, because this is kind of awkward to do around the camera and with all these stiff wires. These are all solid core wires, so they're really stiff. They don't like to bend, and if you bend them too hard, they'll break off right at the terminals where they, on the wire wrap posts. So you kind of have to be careful with that. That's not fun. So I always kind of look back and make sure nothing has broken when I move this back and forth. Just kind of, it's something you have to do. And looking at these caps, I have a feeling that they're probably absolutely perfect. But because they're near these heat sinks and everything on the power supply, and there's not, it's not too terrible. Yeah, there's quite a few there, but it's not really that big of a deal to replace them, so I'm going to do it. All right, let's get this one out. Some of you like this, some of you don't, and that's what the fast forward button is for. See if I can burn my hand while I'm doing this, huh? And of course they glue these on here with that stuff, but it's not too bad. What's this one? 330. And you can see when these are a different width like that, you want to just take these and bend the leads out like this, flare them out kind of almost at 90 degrees, and then move up a little bit and bend it back, and that will widen the leads. You really don't want to pull on where this goes up through here. This is kind of hermetically sealed in there. This bung in here, this rubber stopper, is what keeps the capacitor sealed up, and you don't want to really put a lot of strain on there because that's also a strain relief for the cap, and that's what prevents the lead from breaking loose from the capacitor itself. So if you bend this, that just kind of gives it a little bit of a buffer zone so it doesn't put too much stress on the leads bending out. And then it fits in there a lot better. And yeah, it sits proud of the board a little bit, but that's really not a big deal either. These new caps are much lighter weight than the old ones, and it really won't hurt them to be up there a whole lot. So, and again, people have varying opinions about cutting the leads before you solder them. But two things: I like being able to seal off the end of the lead where I cut it off, and I also like the fact that the extra lead length isn't going to act like a heat sink and carry away the heat. It allows you to transfer the heat to the pad much faster, so your dwell time is a lot quicker, and you have less of a probability of lifting the track off of the board, and that's what you don't want to have happen. So let's put this down in here. This should be the correct one for here. And then we'll put that other one in. All right. I don't know. So what shall we talk about today? I don't know. I do like doing this, believe it or not. Some people think this part of the restoration is boring when you're replacing components like this, but it's kind of therapeutic for me. You can kind of get into a rhythm of doing this, and it's actually pretty relaxing after a while. At least for me it is. Maybe for some of you it isn't. I couldn't imagine, if I did this every day for a living, it might get monotonous and boring. I don't know. But just to come down here like I do, it's not so bad. Okay. Okay. Yeah, and the other thing is I made a comment on an earlier video that I don't consider myself as a teacher on this channel, or that I'm teaching. And I know some of you said, well, that's BS. And I guess in some ways, yes, if you're picking things up from what I'm doing here, and when I say things and everything, yes, it is a form of teaching, but a lot of times I'm sharing things that I've learned along the way, or that I am learning as I learn them. So I look at it as a learning experience as much as a teaching experience. So again, I thank you all for your good comments on that. But I can assure you I get just as much out of this, if not more, than you all do. And what's more, when I say things and get you guys going on the comments section, that's where I learn things as well, because some of the best tips and tricks that I've learned have been ones that I learned from the comments section. Not just on my channel, but on other channels that I watch. Because I enjoy watching videos like this just as much as I do making them. So what do we have here? 220 microfarads at 16 volts. And you look how clean these are. I really don't think these need replaced. Like I said, the power supply is the only one I'm going to do. And then those orange low leakage capacitors. That's it on this one. All right, let me find a capacitor here. On the subject of capacitors, when we did the video of the Marantz 2285, we found out a lot of, at least I found out a lot of interesting things related to capacitors, that some of them left as many questions as they did answers. And the greatest question was, is it important? Why did the manufacturers in the early days use low value electrolytics in places where I know a 50 volt mylar film capacitor could have easily been placed? Even in those days, in the 1970s, mylar film capacitors that were only rated at 50 volts, which was all you needed, were not that big. I mean, sure, they were bigger than the electrolytics, but they really weren't that much bigger. And I know everybody says it's because of cost, but I believed that. I bought into that for a long time. But I'm at the point now, I don't know that I believe that. First of all, I don't think the cost was that significant, number one. Number two, if using a little bit better capacitor would make the unit perform better and give it a little bit of an edge, especially specs-wise. Specifications were a big thing back then. The spec wars were the real deal. I mean, everybody wanted their stereo gear to have better specs than everybody else because that was a selling point, I just don't think they would have scrimped and used a 0.47 microfarad or a 0.1 microfarad electrolytic capacitor just to save a little bit of money. I think there's something to it, and several people in the comments touched on a few really good points, stating that perhaps it was beneficial to have those electrolytics because of the ESR, or because of the how they're polarized instead of non-polarized, that those in some way affected the signal and affected the audio path in a positive way. And of course, I won't say that's a controversial statement, but I will say that it's an interesting statement that we should research a little more. If we can only go back to the folks that designed these things 50 years ago and ask them why, because I'm sure somebody out there would have a direct answer as to why they did that. And I'll tell you, I think about it. It would be interesting to know why they did that. I still think there's something to it. Now, I know, myself being one of them, there are folks out there that say replacing some of those caps with the modern film caps actually makes the sound brighter or clearer, or opens the sound stage, whatever you want to say. And I've experienced that myself. I mean, I have noticed that it does make it sound, at least to my ears, make the sound a little bit brighter. And because of that, I think it's advantageous. But nevertheless, if it makes it sound brighter, that means it changes the sound from the original performance. And the question is, if I would replace those with the same type of electrolytic, would you hear a difference? With a brand new version of that same electrolytic is what I mean. Would you hear a difference? And if the answer is yes, then we can't just discount the electrolytics, because they obviously have their own sound signature. Well, some of you say you're all nuts. You're crazy listening, you know. You're not, you know, you're hearing things that don't exist. And I used to say that. I still believe that in some instances. I do think there is a placebo effect to some degree on some things. But I also do believe that some of these things are audibly different. And you may not notice it under all circumstances because sometimes, I'm digging through my caps, by the way, is why I'm not doing anything. But sometimes you have to have the correct speakers and the correct listening environment and good enough ears to pick it up. And you might say to yourself, well, if I have to have all that, what's the point? Well, touche, you know, maybe that's a valid point also, but I don't know. I've heard some pretty impressive sound systems in my day, and I can tell you they, you know, it is a different experience for sure. You know, to each his own, though, once again. But I think that's all really interesting. And I guess the question remains, when we recap an amp, let's just assume that the capacitors are old and somewhat depleted, you know. Do we stick with the originals or do we go with what we think is better? It's a good question. Maybe it's something, you know, if I'm doing an amp for somebody else, maybe it's something I should ask before doing, because I used to just say, hey, these film caps are better. They're better specifications. They aren't going to have any kind of problems with longevity, you know. And I just thought I'm doing a favor by putting these in. But maybe it's something that we should talk to the owner before we do now. Maybe I will. I'm not sure. All right, this is going kind of slow, so let me finish up the rest of these, and when I get them in, I'll be back. All right, the power supply is all recapacitated and cleaned up and reinstalled, and I'm going to do the motor control board next. So I'm just going to pull that out, and I'm just going to clean it, I think. I don't know that I'm going to have to do much else to it. But just get it out, get the dust off. Make sure we take care of this smoking resistor. All the crud that's on that. I mean, look at this. It's gross. All right. A penny for your thoughts. We've been having some intermittent problems with the display blanking out. And just some things weren't working right when I did test this, although generally everything worked. So I decided, after cleaning off the boards and everything, like I said, I'd take this apart and check it. And I heard something when I took this top display board apart from the controller board. And if you don't already see it, you'll see it when I put the flashlight in there. Can you see it? Let's see if we can get it out. It's really wedged in there, whatever. Let me see. Well, there you go. That was wedged all the way in there. How on earth did that get there? Because this, let me back you up a little bit. This big cover goes over top of the whole thing like this and covers over the whole back and all the way around. So how a penny got up in there, I will never know. But I am going to disassemble this a little further and make sure there's nothing else in there. Okay, a little update here. I just wire brushed off all that rust, and it came right off. There wasn't a whole lot of pitting, a little bit here and a little bit there. Then I took just a thin coat of boiled linseed oil just to seal the metal so it doesn't rust again for now. And I wiped it on there. Now, a couple of rules when working with linseed oil. Do not drink it. Do not breathe it. You shouldn't get it on your skin. And do not use it in a colonic, where your life will be filled with misery and woe. So be careful. More importantly, never ever leave the wet soaked rags in the garbage, in your house, in anywhere. If you wad these up, the chemical reaction of the off-gassing can actually cause these to spontaneously combust, and it will catch fire. I've seen them get warm before. I've never had any burst into flames because I'm always very careful, especially in the wood shop. But when working with linseed oil, be aware of that. But it is a good protectant for metal. And when it cures, it's not really that bad. The boiled linseed oil will actually dry, and it won't be all oily and gross. And it will kind of protect the metal from rust. I'm just going to do that for now because I don't want to deal with taking this out and painting it or anything like that at the moment. All right, we are going to close out this part of the video with two things. Number one, I was able to procure a spare parts, one of these transport assemblies, and it has the same problem as this one. The drive wheel for play and fast forward is warped. It has the same issue, but it has a good rewind wheel on it. So we're going to remove this one and swap it over to here. And we're going to clean it real well and everything. I'll go over that with you, the disassembly of this. And second of all, we are trying out my new camera. I got a new camera. This one is a DSLR body with interchangeable lenses, which I've kind of wanted to have for a long time, so that we can do different scenes. I can do some really close-ups and so forth. But of course, there's a couple of problems with that. Number one, I need to learn the new camera. I need to get the correct lenses for what I want to do. This came with one lens, but there are a couple other ones. And unfortunately, the better quality the lens, the more it costs. So we're going to have to save up some of the money that we get from the channel until we can afford to get a better lens. But it's a good lens that's on this right now. So it just can't get the whole bench in the field of view without getting further away than I normally would be with the other old camera. Anyway, I'm also going to have to get used to the setting up the microphone parameters and everything in this and see how it records audio and so forth. So I'm still using the lapel microphone. I have another stationary microphone that I may try later, but I'm not real keen on those because they tend to pick up the bench noise, you know, when you hit the bench and things. So we'll see. Okay, for starters, I need to remove this little cap that went flying on my old one so I can put it on the new, or, you know, put it over there. And that takes care of that. It just snaps right on like that. And we're going to remove this assembly right here. Same thing. This comes down. You can see it's spring-loaded, so you can pull it down a little bit, and you can just pop it right off. If it's a little too difficult with your fingers, you can use a set of cutters like that and just go under. You don't want to squeeze, but just pull up, and it'll pop that right off. We'll set that aside. Then when we look down in here, we have this little tiny, let's zoom in a little bit if we can. I'll try to stay in frame. The other thing about these camera lenses is the higher quality ones can do autofocus even as you're zooming and so forth. And then there's cine lenses versus non-cine lenses and all these things that I know enough to be dangerous, but not really enough to be any good. So I'm learning, and I'll probably have to ask some of my colleagues about this sort of thing, because my nephew in particular knows way more about this sort of thing than I ever will. Okay, this little white piece here on the top, it comes out as well. And I'm sure the other thing I'm checking is how the autofocus tracks with this. I know as my hand gets in here, I try to focus to that, and then, you know, but hey. I can do fixed focus, but we'll see how it works with the autofocus. All right. That pops right up. And then you want to hold this, because now it's going to fling off of there. And we have that. Then this piece here is just press fit, and it just kind of pulls up. I don't need to pry it. And then this comes off, and then this comes off. And then you want to make sure this little felt pad, see how this one's a little bit oval shaped, it's been distorted. The one on my old one is in really good shape. So this is the piece that we want, and this one is very round, so really it just needs cleaned. And we can do it a couple different ways. If I felt like it, I could set up my little ultrasonic cleaner. Well, I'll do that. Let's do that. Let me get it. Okay, I had a lot of people ask me how I use one of these ultrasonic cleaners. It's really not that difficult. So you take some warm or hot water, and you pour it in, and you spill it all over the bench. And you just fill it up. You want to make sure there's enough in here, or you could ruin the little piezo element that causes the ultrasonic waves, or whatever you want to call it. It needs that water to be in there. Now, in most instances, all you need is water. You don't need anything else. Although, if you have, like the stuck-on rubber and so forth, you want to clean it a little more aggressively, I will use sometimes just cheap, the lowest cost automatic dishwasher detergent. It has phosphates and so forth in it. You don't want to put very much, just the tiniest little bit. You don't need, let's see if I can spill this all over the place too, huh? Don't eat this and all that. You know the routine. So put a little bit of that in there. That's it. That might even be a little more than you really need. Okay, we plop this in. If you want to get fancy, you can use, measuring spoons and measure the amount you want to put in, but you just put a tiny little amount and you start it. And we'll come back in a couple minutes and see what that does. Now, as I said before, you do not want to put anything other than water in here in most instances, especially with certain types of metals and so forth that the chemicals could react or whatever. But in this instance, that little bit of dishwashing detergent will help to release some of the crud off of the plastic. But you have to make sure that whatever you put in there, it isn't going to damage the material that you're trying to clean. I'm just forewarning you. When in doubt, just use water. It works just fine. Okay, the deed is done, and this has been running for a while now. I'm only running it on 5 volts, so it's in slow speed. It has plenty of torque, and everything looks really good. I'm pretty happy with it. And I can run it at full speed, and it does just fine. And we don't see this shuddering around anymore, hardly at all. So this is good. All right, we are going to leave it at that. And next video, hopefully we will have some new pinch rollers. Unfortunately, I ran into a little issue getting mine rebuilt that's actually going to take them longer than I had anticipated, but that's okay. I have another set of pinch rollers coming in, but they're aftermarket ones, and I'm not sure about the quality, so they may be okay, may not, but it's easy enough to pop those off of the little arms as I showed you with, popping those pins out, and those can be removed from the front so you don't have a whole bunch of disassembly, so I'm not really worried about it. So we'll put the new ones on. If they work well, we'll leave them on there and keep the other ones for spares, and if not, we'll wait till our rebuilt ones come in and we'll swap them out then. But I think we'll be good enough to be able to actually use what we have. So I'm going to get this somewhat reassembled, and I think that's it for this part of the video. So until then, I wish you all peace, joy, happiness, and good health, and we'll see you again real soon with the next part. Hopefully this camera will work out for me. We'll see how it turns out. Take care. Bye-bye.